Hello, and welcome to this presentation on decreasing household food waste. My name is Els van Dalen from Delft University of Technology in the Netherlands. I'm presenting on behalf of Jan Wouter de Waal, who is a former student of ours, and the co-authors are Pieter Luning and Bea Steenbekkers from Wageningen University, also in the Netherlands. If we look at the food waste situation, we can see that in 2016 in the Netherlands, per person, more than 40 kilograms of food were wasted per year. This amounts to about 13% of all food bought, and 30% of all food wasted in the Netherlands is wasted by households. Household food waste is a persistent problem because efforts to decrease household food waste in the past have not really led to long-lasting results. So our objectives were to investigate the food waste system in the Netherlands and to assess the potential effects of interventions to reduce food waste. Previous research has focused on specific phases such as storing or buying of food. This research takes a systemic view, and as a point of departure we use the research done by Rothhuizen and colleagues who looked at behaviors related to the food consumption chain. So this food consumption chain consists of the following. First, we plan to buy food, then we actually purchase it, we store it at the home, prepare the food and eat it. And for the purposes of this study, we've added a phase on reusing leftovers. So here we see that food is wasted during a number of phases. For example, if we store food and it's spoiled, we have to throw it away. Sometimes food that's not been prepared well is thrown away. When food is left over, some edible leftovers are thrown away. They are then stored and sometimes they're not reused and also thrown away. There are also some feedbacks we can identify. For example, if we plan to buy a certain amount of food, we look and see what's been stored. If there's a lot in store, we will plan to buy less. So planning to buy less leads to less food bought, less food stored. If you have less food stored, you will plan to buy more. So here's a balancing loop. Another of those loops is that if we waste a lot of food, we will see that we waste food and we will plan to buy less. We'll buy less, store less, waste less, and if we waste less, we may plan to buy more food. So here's another balancing loop. So if we make a highly aggregated conceptual model of this system, we can see that there are multiple negative feedback loops. So the behavior of the system, the amount of waste, is expected to lead to some kind of equilibrium. However, the equilibrium, the amount of food wasted, will never be zero, because in many of the phases there's some kind of overestimation. You will always plan to buy more food than you need, and you might buy more food than you planned, and you will usually prepare more food than you actually need. So in many of the phases there's some kind of overestimation, which will lead to the fact that you will never reach an amount of food waste that's completely zero. So we've represented this model in Vensim, and it gives us insights rather than numbers, because there's a lot still unknown about the causal mechanisms related to food waste, so it will give us qualitative results. The details about the quantification of the model and more about what's in the model is described in the paper. We use the base model to test different interventions on, so we use different types of measures which affect different phases of the system. So the first thing was a fridge cam. Fridge cam can detect what you have in your fridge, and you can use that to improve your planning on the amount of food you need to buy. Second one was to remove discounts from large packaging, which would influence the amount of food that you buy. The third one is a campaign on spoilage knowledge. So if you know more about how long you can keep products for, it will help you storing the food. And the final one was a campaign about the consequences of food waste, so to raise the awareness of food waste. So here we see the same aggregated causal loop diagram in which we've added the interventions. So at the top we see the knowledge of the consequences of food waste, raising the awareness and the perceived amount that you waste. Then there's the effect of a fridge cam influencing the amount of planned food, the effect of removing discounts on the amount of food bought, and the effect of knowing more about spoilage on the food you waste. Here we can see that the base run shows that the amount of food thrown away is a little less than 13%, and each of the individual interventions has a limited effect, where the measure with removing the discounts has relatively the largest effect. So we've also looked at a combination of various interventions. Here we see a combined intervention of removing the discounts and raising people's awareness on the consequences of food waste. The blue line shows the results, and the effects are higher than the sum of the individual interventions, so individually removing the discounts or raising the awareness. This is more than the sum. This is because the awareness influences our perceived amount of food waste, which then strengthens the effect of removing the discounts. On the other hand, if we combine removing the discounts with increasing our knowledge about spoiling food, then we see that this combined intervention shows the blue line, and the individual interventions, so spoilage knowledge in green and removing the discounts, if you add those up, they would be larger than the combined intervention. So in this case, the combined intervention is smaller than the sum of each intervention individually. This is because one of the interventions will reduce the amount of food waste, so then the urgency to further reduce your food waste will be smaller. So this brings us to some conclusions. First, we have to say that this study gives qualitative results at a high level of aggregation because there's still a lack of knowledge about the causal mechanisms of food waste at the level of a household, and the scientific literature uses many different definitions, which makes it very difficult to interpret the data. What we saw in the model is that there are multiple balancing loops, so the system will reach an equilibrium, and different interventions can lead to different equilibria, but it's not possible to use or to avoid all food waste because there's always overbuying or over-preparing. We also saw that none of the interventions had a large individual impact, but a small percentage will still be a significant amount of reduction of food waste. We also saw that combining interventions can have an enlarging effect, but they should focus on how to reduce food waste, but also the awareness of the consequences of food waste. Thank you very much for your attention.